Hello everyone. In this video we are going to look at writing our first LEX program. So today we are writing a program to read input given from the keyboard, and we are going to identify the lines, each line, and add a line number to it. And finally we are going to say how many lines we have encountered in our input. So as you can recall from your previous lecture that a LEX file consists of three sections: the definition section, where we define global variables, we include files, or we create certain definitions. And the second part is our rules, where we have options like this, where we have a pattern, and we have the code which will be executed if that pattern is matched. And finally we have the auxiliary section, where we put some optional code. So here you can see we have, in the definition section, we have some C statements which we have added, and because these two statements, that is include stdio.h, and we have defined a global variable line number initialized to 0. So these are C definitions, so we are putting these inside these two symbols: percentage, open curly brace, percentage, and curly brace. If this was not a C statement, if it was related to the patterns and lexemes, some definitions related to that, then we will write it outside these two symbols. The second section starts with the percentage, okay, and we have the rule section. So in the rule section, on this side we write the rule or the pattern. So remember not to give any extra spaces. Directly from this end, no extra space, we just write the pattern. So dot star slash n, because we are going to count the number of lines, so the end we understand that this is a line by looking at the new line character at the end, and before the new line character it can be any character. So dot here represents any character in the character set of the language, and star here indicates 0 or more repetitions of any character. So this may include just without typing anything, I have pressed the enter key, so a new line is generated, or I type some input, any input of any length, and then I press the enter key, so then also it matches because that is a new line, that's a line. So if there is a match to this pattern, then this code will be executed. And what is this code? This code is nothing but it is the line number, it is printing the line number, and because we want to increment the line number every time there is a match, we want to increment the line number, so we have a pre-incrementation here because we have initialized to 0, and then we are printing the string YY text. Now YY text, we have not defined it anywhere here, so this is a built-in variable of LEX. So what does it contain? It contains the lexeme which has matched the pattern that we have given. So whatever is the lexeme that matched this pattern, that will be stored in YY text, and we are printing it. Okay, so this is the rules. Now here I have only one rule. You may have as many rules as you want, one after the other. Here again also another thing is that here I have only one statement, one C statement. You can have multiple C statements, as many statements as you want, okay, but don't forget to put it within these two curly braces. Then this marks, this 2% symbol again now marks the end of the rule section and the starting of the auxiliary section. So in the auxiliary section I am using the main function. I have created a main function. Now if you don't do this also, it will the LEX will automatically create the main function, but we are doing it because we want something more to be done, something we want to modify how our program will look like. So I have defined the main function here, and then here we are calling YY LEX. So YY LEX is the function which will actually call the lexical analyzer. So this is very important, you have to call YY LEX. And then after calling the lexical analyzer, what we are doing, we are printing the total number of lines in the line number variable. Okay, so this is a regular C statement, and then finally we are returning 0. So this is our LEX program. Let us go to our let us run this program and see. Let's execute this and see. Okay, so we are at the terminal here. I'll just clear this. So I have in my program, in my folder, I have the file line number.l. Now remember to save your LEX files with the extension .l or .lex. So to first compile this program, we will use LEX line number.l. Okay, so LEX is the command and the name of the LEX file we are giving. So once we do this, we will get a file. Here you can see you can get a file called lex.yy.c. So this is the output of the LEX. So what it is creating? It is creating a program, a LEX program, which will have the first part of our C definition, the last part, it is the auxiliary, okay, and then it will have some more code which will actually implement the rules. So after using LEX on line number.l, we get a C program called lex.yy.c. And this is the program which is our actual lexical analyzer program. So remember now that this is a C program, so we have to compile it and to execute it. So we will use gcc lex.yy.c. This is the name of the file, and then we are going to use the -ll options for linking with the external libraries. So what I have now, I have the a.out, the program, the executable. So I will execute a.out. So now it is waiting for, the program is waiting for the input. So let me give the first line. This is the first line. So the moment I press the enter key, it indicates it, the lexical analyzer understands that this is, it recognizes this line as single line, so it matches the pattern, so it prints line number and whatever was the lexi. Let me enter this next one. Second line. Okay, so here it prints line number 2, second line. Now if I want to continue, I can continue as long as I want. Okay, now to end the program or to come out of the lexical analyzer, remember the function was yy.lex. That was the function which was called, so that is repeatedly executing until and unless you press Ctrl D. So when I press Ctrl D, it comes out of the lexical analyzer and executes whatever is there after the yy.lex function. So there we had the printf statement to print the number of lines. The total number of lines is 2, okay, and then return 0. So this is how a simple lexical analyzer will work. Now before ending this video, let me go back and show you one more thing in the Notepad program. So I have said that in the definition part you can define something other than just C statements. Okay, you don't give any executables here, you just give definitions, and we can define something more here. So suppose this is a pattern and I want this pattern to give I want to give a name to this pattern. Just like from 0 to 9, these are digits, I can define them as, I can give a definition like this: digit what 0 to 9. I can give something like this. So similarly for this line number, I want to give something like this: line dot star slash n. So this is the definition. This is the definition. So now this pattern will be known by the term line. So I can replace this here and write line out here and write line out here. Okay, so what we are giving here, this is again another definition, so it should appear in the definition section, but this is not a C definition, so I have to put it outside these two symbols, outside these two symbols. Okay, so all C definitions will come inside these two symbols, Anything other than that will come outside it. So if you want, you can give this before or you can give it after. Okay. So now line, I will use line to represent this in the rule section. So you can compile this program and see, and you will find that this will also be working fine. So in the next class I will show you how to use our Lex program to recognize multiple rules. So that's all for this video.